recording before anyone reminds me. Okay. So let's talk about asynchronous programming. And we're going to think about this using a couple of examples, thinking of what we've already been doing. So the first thing is the title of this is callbacks and following the flow of control. This phrase here, following the flow of control, is seeing how quickly and how much you can read code and understand the way that it executes, all right, forming that flow in your head. And that skill of following the flow throughout a program, when you read code that you haven't written or read code that you have written, we've got to keep improving this skill. So you can visualize how code works without having to run it yourself. So whenever you hear this phrase, I want you to think about it as the order in which parts of the code are executed and having them in your head as some kind of visual representation, whatever you need to do to figure out what is the order in which parts of the code are executed. We're going to also think about a process that we can use to follow the flow of control. And the main process we're going to be using in this example is using console.log and numbers to sort of figure out what order things show up. Right? And then we're going to follow this in different examples to understand how callbacks are working, what even is a callback, and how does this relate to asynchronous programming as opposed to synchronous programming. He just sent me a message. I'm going to ignore it. So he sent me a message. I'm ignoring it. So let's have a look at an example. This is simply the same directory from this workshop that I'm inside of it. All right. So I'm going to go to this this file here, so far all of our programs that we've been writing get executed one line at a time in the order in which you write them. All right. So you wouldn't expect when you run this program, you wouldn't expect line 3 to happen before line 1. All right, that's not an expectation, right? You would expect this will happen before line 3. All right, so if we run this program, the way that I'm running this is I'm going to use my browser to open my HTML file, and my HTML file has 2 scripts. It loads a library from jQuery, which I'm not using just yet, but it loads the index file. So it will load this JavaScript. So when I run it in my browser, I expect to open my console and see some console.log statements, all right? Can you see it all here? Maybe it's a little bit bigger. That's a bit too big. All right, quite reasonably, hello appears before bye. All right, nothing crazy about this. This is just making sure we understand the idea of synchronous programming, something giving a name, something we've been doing before. Things are being executed in order. When async programming happens is when things don't happen in the order in which you write them. So let's take this example. And I'm going to put it in my file here. Now, let's think about the order in which things are happening. Rather than think about it, let's try and use our console.log statements to sort of think about the order in which the code executes. So I might reasonably expect when I run my program that my console will have the number 1 printed to it. Let's keep going, and I'm going to add the number 2. I want to remove that. I'm going to have the number 3 after the click, and I'm going to have console.log 4. All right. This might be your first step in thinking about the order in which things are happening. You read through your program. Lines are executed in order, so you might start off here with thinking about the order of this program. All right, so when I open up my console, I expect to see the numbers 1 through 4 printed. Let's have a look. However, that's not the case. All right, only numbers 1 and 4 are printed. So when do numbers 2 and 3 get printed to my console? Well, they only get printed once this function here executes. And when does this function get executed? When there's a click event. I clicked on my screen if you weren't paying attention. I keep clicking, and I keep printing out these sets of numbers. All right, so you've all been doing some async programming already, maybe without realizing it, but we're trying to give a name to it now, and trying to think about, if we see this in future, how can we visualize and how can we follow this in programs? Let's go back to the example. We have a console log statement here that happens, gets executed. The add event listener function gets invoked. Now, this function doesn't get executed yet. So the add event listener completes its invocation, it completes, and then we console log 4, which is why at the very beginning we see 1, then 4. So this function here hasn't been executed, even though it appears before line 9. All right, this is something that we'll spend some time thinking about. All right. This function only gets executed once the click event happens. So I'm going to click on my screen, and then it gets executed. So what you're looking at is a very simple example of an asynchronous bit of code, and it starts off with the add event listener. So the add event listener has a function that doesn't get executed straight away. It waits. It waits until a click event happens. So this idea of having functions passed to another function, so we're passing this function to the add event listener, is not new. All right, we've been doing this before. You might have the common examples you've seen was anytime you're writing any of your tests, you're passing in functions to the describe and the it. There were 2 arguments. It had a string description of the test, and then you pass in a function as the second argument. That's a callback. Maybe when you're using like a map function or a for each, when you're looping through an array, both take callback functions. All right, a bit of code to execute for every item in an array. Those are not asynchronous, they happen immediately. So we've seen callbacks before, and there are some callbacks that will happen asynchronously, and there'll be some callbacks that happen synchronously. And it all depends on this function here. Is this asynchronous or is this synchronous? So the add event listener of a function is asynchronous. It waits until there's an event that it knows and then executes it later. So your task is to use your console logs with numbers and practice in different examples, reading through a bit of code, adding your console log statements and seeing what happens. So I'm going to ask you to pair up to do this together. Do what I did, navigate into this workshop's directory and open the HTML file in your browser. So you should have something like this, and you should see the result in your console. Open up the index.js file here, and this will be where you're going to be doing your practice. All right. For each question, paste the provided code into index.js. So this is the one that I've added here. Now notice this question 1 uses the jQuery equivalent of, if I get rid of the console logs, we'll see the comparison. You'll be able to see something that is essentially the jQuery equivalent of the simple JavaScript version of this. All right, this $sign comes from jQuery, and the only reason we have this available is because in my index of HTML, I require jQuery. So the $sign encapsulates all of the jQuery behavior, and we can access it through the $sign. And so I say, get me the document, add the event listener click, and when it happens, do this thing. So in your first question, just copy this bit of code and then add your console log numbers wherever you want to understand the flow of control, the order in which things are happening in your program. The first question is just about the order. The second question, make sure you go through the questions, or the sub-questions for each question, and have a look at how it's working. There are 5 questions, and spend your time console.logging and maybe do some research to answer some of these questions, and then we'll gather back and discuss them at the end. All right. So the 5 questions, I expect it might take more than half an hour. So the time is 2:37. Let's round up to 2:40, and let's have 40 minutes to see how far we get. So 3:10, and then we'll discuss. There are a couple more resources if you want to do some later sort of research yourselves. But the main objective for everyone is to go through and figure out the order in which things are happening. And when you things that you are coming across that you don't know, just do some research, have a look, console log as much as you can to see what's happening. All right, there'll be new things here, and that we'll then discuss together as a group. Okay, thoughts and questions to make sure you know what you'll be doing for the next 40 minutes.
You just said 3:10, but I think you meant 3:20.
Correct.
That is all.
Any other thoughts and questions? Great. Pair up. I'm going to split you all up into breakout rooms, and I will do it this way. Did I forget to record this? I think I forgot to record this, didn't I? Jesus. All right. Thanks.
No, you recorded it.
I'm pretty sure you were recording, yeah.
Oh, I am. Look at
that. I'll have that at the end.
That's worth a trim. All right. Breakout rooms. Breakout rooms. Create. How many are we? I think we said we were 16 or 17. So let's do 8. And that means all groups of 2, one group of 3. And any questions, ping me. Otherwise, see you back here at not 3:10, 3:20. Okay. Cool. And move you folks out of the way. And what did I just do? Let's go to that. Okay, so let's start with this one. We attempted to do a post to the URL, but it didn't work. All right. Well, 5 points to Gryffindor for thinking outside the box. What was the intention here?
The point was to try to see if a post takes longer than a get. So just playing around, to be honest.
Cool. We won't come on to this until probably until, well, definitely the week after next. And we might experience some of this next week. But in general, this word here describes a kind of request. All right. Now, we'll formally talk about this when we go into our web application unit, and as part of our sort of module talking about how that side of the technical stack works. And we'll do a lot of talking about how a client sends information to a server. All right. So you might have already seen this diagram being drawn before, client and a server relationship, where the way that these two things communicate, there are a few different protocols, but the one that we're going to focus on will be HTTP. Right? How do we send requests? How do we get these things to communicate via HTTP? All right. As you might already know, this is like the main way that we can communicate. You send requests to get information. So if you open up a browser, you go to bbc.co.uk. This sends a request to get information from the BBC servers. So a post request is a kind of request. There's a bunch of kinds of requests we can make, but the way that they have to work is you have to set up this side on the right-hand side. This has to support the kinds of requests that you send. So it's like, think of it like writing an address on an envelope. That's on this side on the left. So you can write all the kinds of different requests that you want, but you have to make sure that that house actually exists, for example, to receive that request. So in order to complete a successful post request, you have to have on your server a way to handle those kinds of requests. So it's very likely that when you make a post request, there was nothing to handle that kind of request. So it was like, sorry, don't know what you're doing. All right, so both parts have to match. Again, we'll talk about this more formally when we start our web application unit. But yeah, 5 points for thinking outside the box here to try and have a different kind of request. Oh, it's like a little spotlight. Let's move that over here. What's this one? If I return people response from the get function and I assign some variable to that response, why aren't the variable and the people response the same thing? Cool. All right. I'm glad this was brought up. Let's have a look at a bit of code. If I return people response from the get function and I assign some variable to that response, why aren't the variable and the same thing? Was it like this one? Was it question 3? It was returning from it. Yeah, right. And I assign some variable to the response. If I return people response and around the variable and people response, the same thing. I imagine this is what you're trying to do, right?
Yeah.
Yeah. Okay. And the question is, imagine we were trying to do something like console.log people response, and then you wanted to do console.log get return value, correct? And you're saying these two things are different.
Exactly, yeah.
Yeah. Cool. I'm glad this was brought up. So let's see this happen. I'm going to open this up in my browser. Are you the right one? Yes, you are. And these are two different things. Notice the order in which they happen. Which one happens first? The console log on line 4 or the console log on line 8?
Eight.
You can see here, the one on line 8, yeah? So this happens first. So this is a really important point. When we think about async programming, you can't return from an async function in the way that you think you should. This return value does not return from the get function. All right, the get function is all of that. All right, the get function takes 2 arguments. well, it takes more than 2 arguments, but at the minimal, it takes a URL that you want to send a request to, and some kind of function to run. Yeah, so that's the basic format of the 2 arguments for the get. All right, so you can, if you wanted to, you can set them independently. You can set your URL to be whatever you want it to be. You can set your function to be whatever you want it to be. So let's go with something like this. All right, you have a function that console logs whatever is the argument here, and then tries to return it. The URL is this thing here. So this is essentially what's happening, right? I'm trying to get you to look at this. So when I invoke this function, I'm not invoking this function, I'm just passing the function in. All right, we can pass functions around without invoking them. So you were trying to essentially say, I want to log, I want to return the people response, but this function hasn't been invoked. So what's the return value of calling the get function? The get function, as you see here, just returns this request object. Right, this is the object that represents the request. And it returns it straight away and then waits for any of the response to come back. So as soon as you call the get function, it returns to you the request object, not this thing. This doesn't actually, well, it happens, but doesn't return to the right place. So this is redundant. All right, this doesn't change any behavior of your program. All right, if you pass it in as a callback here. All right, important to note. All right, so the original way this is written is to get you to remember and get you to experience the fact that this return value does not get stored inside this variable. What gets stored inside this variable is the return value of the get function. The get returns the request object. Right, it doesn't hang around, doesn't wait for that to complete, because this is the point of a synchronous program. We don't want to wait for things to complete. We don't know how long they're going to take. And so we want to keep our program executing. And then when it does complete, it then gets put back onto the stack and then executes. So we can keep moving forward. We can keep being unblocked in the way that our program runs. And when the response comes back, then we can log it to the console or do whatever the function wants. So passing in a function to get executed at a later point in time, which is why this return statement is redundant. Does that make sense?
Yeah, so it's although the variable get return value doesn't get assigned the return of the .get, it still gets assigned to .get as like an incompleted request.
Well, it just gets returned as the request object. We don't know whether it's complete or not, because that's the responsibility of the server. Oh, almost threw my phone off my table. The responsibility of the server to send back the information, and then the request will be a state of complete or rejected, or whatever other states there are.
Okay, cool. Thanks.
So the get function is written by jQuery, and you can have a look at its return value. It's a function that someone else has written that we're using. It returns a request object. And we just got to get in the habit of being able to follow this. And a common mistake, because we think about synchronous programming, is that we can return from it and store it. So the follow-up question to this, if we want to use the data that we get back from an asynchronous call like this, we have to make sure we use it inside of this function. All right, we can't use outside of it. So whatever you need to manipulate, whatever you want to do with it, it would happen inside of this callback function. And so you would get a nested program. Make the request. And if you need to manipulate that data or use it in some way, we would do it inside of the callback function.
So what's the value then of saying let get return value equal to that, if it's never going to be the same as that?
If you ever wanted to use the request object, which is unlikely, but this is to get you to understand there is a difference between the two of them. This is
Got it.
what people try to do to begin with, and then realize it's not working. And this is why it's here as an example.
Okay, thanks.
Good question. I'm happy this was brought up. That's what I would have brought up anyway.
So this isn't actually something that you do. This is an example of something that you don't do.
Exactly.
Oh, okay.
Unless you wanted to play around with the actual request object, which I don't imagine anyone would want to do. Cool.
Right.
Okay, I'm able to index and call for each on it. What is it? Well, I can't remember what it is. It is an array. You can see here it's an array of objects. It's got 4 objects in it, so you can loop through it and manipulate it as you would an array. When we make the request, the browser is a kind of client. It's a very sophisticated client. So if you were to look at that URL in your browser, you still make a GET request to it in the same way. And the browser then tries to render that data. So this is what you get. It's an array of objects.
When I call type of for it, it says it's an object. Am I doing something wrong there?
I don't imagine you're doing something wrong. It returns an array. So you can see it's an array that has the same properties as an array, and you can it's got an array of objects, and you can find different elements of it.
Okay, but so why does it log object if I do type of people response?
Let's have a look at it afterwards, right?
Sure, yeah, that's fine. Thanks.
Cool. Doing set timeout of -1000 doesn't do anything. It just works as 0 to try to get it before the console.log1. If that could actually work, I'd be incredibly impressed, and would probably think that you have magic powers to go back into time. Set timeout will always, and you pass it an argument of a number in milliseconds to execute at least that amount after. So -1000 makes no sense, but it's fun to try. So this doesn't look like a question, it just looks like a comment that if a negative number doesn't really do anything, it just works the same as passing in 0 as your argument to it. Was there anything else that you wanted to talk about for this one? Is there a way to see a function is async in the code editor? Interesting question. You would have to have some kind of plugin that looks up functions to see what were like the documentation for them, and that might give you a sense of whether it's async or not. Otherwise, in general, the main async functions are any kind of HTTP request that we're making, set timeout, and there are a couple other ones out there, but the main reason we're talking about this is because at some point soon, probably in the next day or two, you're going to get onto the point where we're going to make requests to external APIs to get data, and all of those requests are going to be asynchronous. All right, so the main way that you're going to be using async programming is by making requests using either jQuery's like get or post method, or there's a couple other things that we might use. But so far today, we've been using jQuery because it helps keep some of the bloat down for the way that we would have to write these requests otherwise. So jQuery is just JavaScript as a helper library that we have access to. So in answer to this question, there probably is, but I'll have to go double check for your editor about, is there a plugin for it that will help you do some quick research? You hover over like the function and you go look it up on the documentation for it. But otherwise, you don't need to worry about it because the main way that we'll use it will be any of the request methods like get or post from jQuery. And that's going to be pretty much 99% of the way that we'll use async programming, all right? Sound good? Cool. Thumbs up, one thumbs up.
Ed, sorry, the people response function that you pass to the API, does that mean that the API has that function within it and you're just calling that function on the server side?
Not quite. Let's extend you left. In reality, we have what we call a stack. All right. A stack is, as you might imagine it, think of it as like a, I don't know, set of pancakes, go from bottom to top. All right. And in order for a program to work, we put functions or anything that needs to be executed onto the stack. This determines the order in which things happen. And once they get executed, they pop off the stack. So you might imagine in a typical program, we could put, let's just put like, for example, one layer here. And imagine we had another layer, then it's always whatever gets put on first on. That's not really a good spelling. Let's redo that. First on is always last off. All right. So the way that this would execute was always whatever's on the top gets popped off first until we get back down to the bottom. All right, we go up and we go down. What this is to say is this is the normal way synchronous programming works. We don't get to any of the bottom stuff until the top stuff is finished. Now, when we enter async programming, there's actually what we call a second stack. And this is where those functions go to then be executed at a later point in time. And they get put back onto the stack. There's actually a little holding queue here for those things. So this is all within your browser, all right? This is the browser has got a JavaScript runtime environment, and it can handle these asynchronous cases. So imagine your GET request. Let's imagine it's anything on here, so we can model it a little bit more simply. The GET request pops onto the stack. Let's imagine it's as simple as this, and it's got inside of here, and make it a little bit bigger, some kind of other function to run. The get function executes and returns that object, all right? But this function is asynchronous, so it gets put over here, and it waits to get to be run. All right, so this then disappears off the stack, and our program continues to run as normal. And at some point, this function will happen. All right, and there are a few conditions for this to work. The GET request needs to have executed, and you have got a response back from the browser, and then we can do something in the case of a GET request. When that happens, this function then gets put on as a waiting to say, okay, we're now ready. And when it's ready, it gets put back onto the stack, and that's why you'll see any console log or anything that happens in your program. So that function is not is entirely within the scope of your browser. It doesn't rely on anything to do with the other server that you're making requests to. The thing that the server has to be able to handle is the kind of request that you're sending it to, the path of the request, so that URL, does it have the right address, and any data that you send across with it. And those are the things that the server has to be able to recognize, right? Think of it as it has to recognize the address on the envelope, and then anything inside of it is still on this side, on the browser side. All right.
If you initiate one of those set timeout things, would that stay on the stack for however long you initiate it for, or would it just come on to the stack?
Set timeout is the same way. Set timeout pops onto the stack, finishes, it sets it up, and then leaves the stack. And that function that you say, please execute at least this amount of time afterwards, it goes here. The timer counts down. When it's finished, it goes here. And that's why it's at least that amount of time afterwards, because there is still, it's not, you can't rely on a set timeout to always execute exactly that number of milliseconds after it happens, right? It waits, there's a timer here that says, okay, it's an asynchronous function. That function then is over here. It waits until that countdown has happened. Then we pop it into here. We wait until this execution is finished, and we pop it back onto the stack to resolve. All right. And so this is diving a little bit deeper into the way that what we call is the event loop for JavaScript in the browser. And there's a really useful video if you want to watch it. There's a really great description of it down here. All right. So go explore it at your own time. I recommend everyone to watch this to get some more context about how the asynchronous functions get executed at a later point in time. All right. So this is an answer to, I think, your question, Grant. How happy are you with that answer?
Well, I'm still pretty confused, but I think I should research it myself. Okay. Perhaps. I'm just so I don't understand the people response and is taken as a parameter in the function. Does that come from the API? So the API has something in it called people response, and then you take that in and return the whole thing. I just have no idea what's going on. This is just a
variable name, this part here. Yeah. So this is just a variable name. You can call it anything that you want. People sometimes call it data, and just make sure it's the same thing. All right. This is simply a function that says.
I'm sorry, my headset just died on me. I have to go over here close to the thing now, close to the charger. Can you start again from when I stopped talking?
Sure. You were talking about the name of this variable. The name of this variable doesn't matter. It's just a name.
Right.
It's just an argument that says we're going to pass the return value of the result of saying this request gets stored here. So this address here, when you send a request to it, will give you back some data. It's responsible for sending back a response. That response data is passed the argument of your callback. This is all within the get method for jQuery. All right, someone's written a jQuery a get method like this, and some kind of, imagine this as some kind of jQuery thing. Someone's written a get method that takes in the URL and a function, and then we'll execute that function with some data. All right, and it gets that data back from from the response. So here it's like send a request to the server, get back data from the response, and then execute your callback with that data. All right, so this function needs to be able to have an argument for it to be able to do anything, which is why you specify this argument here. It's just a name. Right? You've got to give it an argument so that when it gets called, it has access to it.
Okay, so the return obviously wouldn't do anything in this scenario, but usually you'd use that data to do something else with
Exactly.
within this function.
Is redundant, yeah.
Right. Okay.
So this is just an argument that we're passing the function because this is what the get, whoever's written the get method is expecting it, how it expects to be used.
Oh, right. Yeah, because you were using this as an example of what not to do, and then I've just got really hung up on it.
Yes. Yeah. So this is all within under the hood for the get method. It expects two things: a URL and a function. And that function it expects to have an argument, which is why we pass an argument here. We don't have access. We don't have access. It would still complete, but we don't have access to any of that data, so we can't manipulate it. So you can
Okay, I think I'm quite happy now.
Yeah?
Yeah.
I'm glad you're happy. But in all honesty, does that help other people? How we feel about this at the moment? Some nods. Yeah. Cool. Okay. What happens if you have two gets in your program? What order do they get executed in? Interesting question. Imagine you had these two here. Now, the synchronous part, this will execute first, right? It will turn its request object. This then gets executed. But the async part here, these inside functions we get passed, entirely unknowable until you executed which one happens first. Because it depends on the server. They might get sent to different servers that might have a different response time. And so we can't control the order of those things happening. Yeah, so this get happens first, this get happens second, but these callback functions, we can't control when they get executed. They're entirely dependent on the response of the server. Yeah.
Is it possible to somehow control them a bit by setting the timeouts, by like controlling the timeout or something to make one like really long or something to try and, I guess, guarantee it a little bit more?
If you needed to guarantee it, you would write using a slightly different way. Right? You would, if you're using jQuery, it has a promise-like structure. And so you would then use a then statement or a then function to chain and say only execute this once this is resolved. And you would put this function inside of this, where it would be something like, I don't know, you probably wouldn't need to use probably will look something like this. We wouldn't need to use this, so you could probably get rid of it. So this would say only run this inner function once this has been resolved, in order to force some synchronicity in this. All right. Don't worry about this at the moment. We'll cover this soon. All right. This is an answer to the question. If you had to guarantee some synchronicity in your calls, this is how you would do it. So if you're interested, go look up .then. We'll have a little bit more work on promises and promise-like structure that is supported by .then and things like that. Cool. We noticed that even with a set timeout of 0, sync processes work before async. What does this mean? Give me context. Have we already answered this? What can I do? Is this a question? Shall I move on?
I didn't ask the question, but I sort of also have that question, which I think is what they're asking, which is, even if you say like wait for no time at all, it still does that thing last, if you know what I mean?
Yeah.
It doesn't do it immediately, it still waits, even though you've said to it to not wait.
You've said, great point. So this is still, whatever, if you use set timeout, it's still an async function. All right. So if something like, you pass in the function first, I think so. And then you pass in the amount of time afterwards, right? So this, remember, set timeout will return first, set it up, and then your program will keep going. And then whatever is inside of here will then execute. So you're not saying execute this first and then execute the console log. You're saying we'll set up our set timeout to happen at least 0 seconds afterwards. All right. So that afterwards, that at least part says, okay, we'll wait for our stack to be clear and then we'll execute it at least 0 seconds. So this is still asynchronous and we'll then pop back onto the stack. All right.
So if you had like 100 console.log by statements underneath, it would do all of those first, then go back and do the console.log within set timeout. Okay.
Yeah. And this is in milliseconds, all right? So if you wanted to wait 1 second, you would do 1,000. Cool. Setting events with the same timeout means they execute at the same time in the order written. Cool. If you imagine it on the stack here, you pop them all onto it, and their timer starts. So you'll have a bunch of different functions here, all counting down, function, 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 and when they all complete, they go back onto the stack. So there's still an order to them. And so as long as the set timeouts are executed and they all have the same timeouts, I imagine they'll all still retain the order in which they were sent onto their stacks. Does get take longer to run because it has to process information from the URL. Yeah, if you think back to this small diagram here, when you make the GET request from your browser, it sends a request via HTTP to the server. The server then has to handle it and then send me back a response. So you can, there's probably another thing that you probably don't have to worry about just yet, but if you wanted to have a look at it, if you go to your network tab, I've got rid of it, so let's go grab that code again. Simple one is probably this one. And then refresh your page, you can kind of see the things that are happening inside of your Chrome DevTools, whatever DevTools you're using for your browser. You can see the different things that are happening for this request. Now, I don't want you to worry so much about this because we will cover this when we get into the web application and understanding more about the request response. And this is an answer to the question of, well, does GET take longer to run because it has to process information from the URL? The length of time it takes to run is all about the different stages to this request. There are different things that have to happen. You can see some of them happen super quickly, 2 milliseconds, 1 millisecond, 40 milliseconds. That's quite quick. The connections are taking a little bit of time. The encryption takes a little bit of time. And then we send back the request. The request is super quick, 0.13 milliseconds. And then we have to do any downloads and things like that. So there are different stages to the request and response, and they are the responsibility of your browser doing things, the server that you send the request to handle things, and then send you back some data. So these are the different things that happen, which we don't control. All right. So this took about half a second, just over half a second. So high-level view, yes, things take some time because it has to go to the server and come back, and we don't control a lot of that process. Where are you? Where's everyone gone? Over here. Cool. Anything? Any other questions or any other thoughts that we're here? Some of you haven't pointed it out, but this last one, no, the one before this, this example question 4 was making sure you realize that even though we're passing this callback as this function as a callback to the for each function, it's not asynchronous. All right, for each is not asynchronous; it is synchronous. It happens immediately. All right, so callbacks, functions that we pass to another function that get executed, are either asynchronous or synchronous. And this is an example, one that you're probably already familiar with, looping through an array. We pass in a function as an argument. Just because we pass in a function argument doesn't make it asynchronous. It depends on the function that we call. All right, for each is not async, whereas these GET requests are. Cool. Anything else? Anything else that pop up from this session? So the biggest takeaway from this is making sure you have the process now to follow whenever you're thinking about the flow of your code, is make sure you're constantly logging everything to figure out the order in which things are happening. It'll be a useful process to follow. All right, let's wrap there. Stop this. Stop.